Hey guys, thank you so much for making time out of your busy ETH Denver schedules to be here. Today we're going to talk about an intro to Cadence using the hello world as kind of like a prompt to explore some of the different conceptual considerations when you're actually starting to develop a contract and running transactions and just creating on-chain systems on Flow. So a little bit, just an overview about what we're going to cover, QR code for the slides for some of the later references could be helpful. Why Cadence? We're going to start out there. I got to start out with motivation. Why should you care? And then we're going to jump right into Flow Playground, and we're going to create and iterate on a hello world contract, starting out really basic, and then looking at what does resource-oriented access control look like and capability-based access control look like. We're going to use the playground to run transactions and scripts, talk a little bit about the transaction model when you're running transactions on Flow, and then we're going to deploy to Testnet, run transactions and scripts there, take a look at some in-browser tooling and local development tooling. Once we get deployed to Testnet, we can use some of these tools to actually explore Flow's account model, which is pretty important consideration when you're actually designing your contracts and constructs. And then, of course, talk about some of the absolutely critical tooling like Flow CLI and your Cadence VS Code extension. So really targeting anyone who's starting fresh with Cadence, hasn't really interacted much with Cadence. Can I get a show of hands how many people have played around with Cadence just a bit? Cool. Yeah, so pretty decent amount. Yeah. Cool. Well, yeah, of course, ETH Denver being an EVM developer-focused event, we'll kind of like map some of those mental models over to Cadence, so that could be a little helpful. But starting out with why Cadence? Why should you learn Cadence? Well, we're going to get into the transaction model in a bit, but Cadence, the transaction model on Flow allows you to abstract quite a lot, make various contract calls as much as will fit into the computation in a single transaction. So you can actually compress quite a lot of complexity into a single user confirmation. So it allows you to take a much more product-focused approach. And for anyone who is interested in building EVM first, you can sprinkle just a little bit of Cadence into your user flows, and using that transaction model, execute several 10 EVM operations that would otherwise take several confirmations and several user interactions into a single confirmation. So you use it in a really targeted way, even if you are looking at just the EVM side of things. So let's break out of these slides. It's pretty much the only one I have. If you do snap that QR code, you'll be able to access any of these docs and tools that will be covered here. But we're going to jump right into Flow Playground. So I'll enlarge that just a little bit so you all can see. And we're basically just going to be looking at code here. So what I have here, if you go to play.flow.com, if you go there for the first time, you'll be met with a similar hello world. There'll be a little bit added on there that we're going to iterate towards. But just declaring our first contract in Cadence. So what does this look like? We have a contract, access all contract, hello world, and we have a greeting field, right? It's pretty bare bones for just being able to put your greeting on chain. So we have a field here, and this is a constant. So we have access self greeting. Let's go ahead and make that access all to make it public, and an initialization block. So for any data structure that you have, a resource, contract, otherwise on Flow, you have to initialize that. It's only initialized once, of course, and we can go ahead and deploy this contract. So I'm going to select one of the 5 accounts here. When you deploy a contract, it'll actually be deployed to that same account. So we just deployed to account 6. Any account that you're dealing with in Cadence on the native Flow side is going to be natively abstracted. So you can store code, you can store data. And so when you deploy the contract, it's going to be deployed to that same address. So we've got a greeting. Let's read that greeting. On the left here, you're going to see contracts, you'll see transactions, and you'll see scripts. Scripts allow you to access data from the contract. So we can go ahead and get that greeting. We can access data that's stored on contracts or accounts, as we'll see in just a little bit. So I'm going to run this script. Whenever you run a script, basically the function that's called is the access all fun main. And here we're returning a string. You'll notice that Cadence is pretty strongly typed. So we'll execute this script, and here you'll see some prior runs where I got the result, and you see hello world. So I'm going to clear these. And let's start kind of adding and expanding on this contract just iteratively. So we have this public field, but it's not really helpful if we just deploy this and just have this one field just set once. So let's go ahead and add a setter. And I'm going to make this setter access all, and I'm going to take a new greeting. It's going to be a string. I'm not going to return anything, but I'm going to assign greeting, self.greeting, as the new string that I get. The problem here, of course, is I declared greeting as a constant, so I'm going to have to change that to a variable, and that's just going to be a variable here, and I'm going to redeploy that. I'll just deploy that to the same account here, and we'll go from the script that we just ran to a transaction. Transactions are going to be mutating, and transaction model will be broken up basically into two blocks. So you'll have a prepare block and an execute block. I'll take a cooking analogy, basically. So if you're going to cook and execute, you got to prepare what you're going to cook in the prepare block, and that's where you'll have access to the authoriser's account. So anything that's stored there. Since we made our setter public, you can see that's access all. Anyone can call this. So we don't need anything from the prepare block. We'll go ahead and just call that function. So hello world.setGreeting, we're going to go ahead and give it a greeting. I'm going to make my contract multilingual. Proud to sing my Spanish, so hola mundo. And just to show you that anyone can run this, I'm going to select another authorizer and hit send. And just a note about Flow Playground, it's basically just a local environment. So it's like a little local blockchain. So that allows you to iterate pretty quickly. So we're going to go back and get that greeting after we've updated it, and we should see our updated greeting. But this isn't all that helpful, because if you could imagine the state for this being reflected on like some Times Square billboard, you get some pretty crazy messages if you just allow anyone to set it. So we want to restrict the access. And if anyone is familiar with other programming languages like Solidity, especially contract languages, you might say, well, I guess what I'll do is I'll check message.sender, and message.sender is going to have to equal some owner, right? But actually in Cadence, with a resource-oriented program paradigm, I'll borrow Dietz words. It's not who you are, it's what you have. So we want to actually give this account something that will allow it access on the contract. So what does that look like? So first off, I know that I need to restrict access on this contract getter. So I'm going to make it access contract. So I'm going to restrict the access, but now, as you notice, like we don't have a way to actually call this method from outside of the contract. So we're going to go ahead and define what's called a resource, and a resource is a very special type in Cadence. We'll deal with them a lot. I'm just going to call this resource admin, and the admin, I'll go ahead and add that getter, or I'm sorry, that setter. So I'm going to go ahead and add this method. I'm going to make it access all, which for a second may be a little confusing. And I'm just going to call into this hello world set greeting, which I can do because that method is access contract. So I've just updated my contract. I still have the same field. I still have a setter, but as you notice, you have to have access to the admin to actually call that setter. So we're going to deploy this to that same contract account 6. We'll deploy that. Our contract will be deployed. And if we go back into that transaction, we'll see, hey, actually, I'm getting an error here because set greeting requires contract authorization, and we're not in the contract. So how do we actually get access to that admin? Well, one thing that we missed here is this admin needs to be accessible somewhere. We didn't even create it. So again, we have this contract initialization block, and that will allow us to create the admin, but you need to put that admin somewhere once you create it. And we'll see here in just a minute what it looks like to deal with resources. So this is going to be a new operator. This is going to be the move operator. And resources this is about as good of an analogy as I could come up with, is that they're hot potatoes. So if someone hands you a hot potato, you're not going to leave it in your hands. You have to do something with it. You have to hand it off, or you need to, I guess, eat the hot potato. So let's see what that looks like, right? So I'm going to create this admin, and I'm going to immediately get an error, right? I'm hanging on to my hot potato, and I'm getting a loss of resource. I can do one of two things with it. I could go ahead and destroy it, but is not going to be very helpful. I can, let admin, an error here. So I've created an admin resource in memory, and I'm immediately destroying it, right? So that gets rid of my error, but that doesn't really help me much because I don't have access to the admin beyond this. So what I'm going to do is I will actually store this admin in the account where this contract is deployed. So we have access to the account storage from the contract.storage. I'm going to access the account storage, and I'm going to save that. Similar to how we moved to use the move operator when we created the admin, I'm going to move it into storage. And I'm just going to save that into the storage namespace, which is similar to like a file path. So you'd have storage, and I'm just going to go ahead and name this as hello world admin. Hey, welcome guys.
Hi.
Yeah. So just to recap, we've created this admin resource, and we've just saved it into storage inside of the initialization block. So when we actually deploy this contract, the greeting field will get set, and the admin will be created and saved. Awesome. So we've just deployed that to account 6. And now our change greeting is going to look a little different. We're going to need to actually prepare for our cook and the execute. So I'm going to need to actually call this from an admin. So that's where we're kind of headed. And I need to have an admin accessible. I need a hello world admin.admin. Resources, as I mentioned, you have to, once you have them loaded into memory, you have to do something with them. But in this case, we actually don't need to load the admin from storage. We can just reference the admin that's already in the authorizer storage. So I'm going to go ahead and assign this admin by referencing the admin inside of the signer's account. One thing we do need to consider here is the scope of access that we need on the signer. So if we're going to be accessing the signer's storage, we need to authorize the transaction to access that storage. So you can actually have, you can issue like different aspects and attributes and functionality on the account object from the transaction, and that helps for example, wallets know the scope of access and change that's going to be available to the transaction code. So I'm going to go ahead and authorize this as storage, and now that will give us access to the authorizer storage, the signers here, and we'll access that as storage. I'm going to borrow a reference, and remember we stored that in hello world admin. I'm just going to go ahead and declare the type here. So when we're accessing something from its storage, we need to declare the type. Sorry, this is getting in the way here. We need to declare the type of the thing that we're trying to access, and it has to be there. It may not actually be there when you try to access it, and so the value for admin may or may not be returned. It could be no. And so one thing to note in Cadence is that you do have optional types, and an optional type is something that could be no if it's not there, if it's not assigned. So we need to handle that optional. I would typically advise, unless you know for sure that something will be there, that the non-no value will be returned, that you just basically do a panic and you execute an error message. So I'm just going to say no admin here, and now you can see we've resolved any sort of like linter errors. We have our admin, we've prepared our admin, and now we can cook with our admin in the execute block. And we'll go ahead and set that greeting. So it started as hello world. We'll do our typical little translation. And just to show you that access control is functioning as we expected, only account 6 will be able to execute this. I'm going to try to execute this with account 7. And I'll send, and I should get an error because there's no admin there. Exactly. So let's clear this and run this for real with account 6. Should still have this, and I will send that, and I should get, let's see, sometimes it doesn't redeploy, so let's try that. There we go, and now errors, no errors log. I will say hola mundo. Make sure I have account 6 selected, and I'll send that transaction. Now, sometimes what you will see is exactly what I did, which is I mistyped the storage path. So that's a little live thing. Let's just go ahead and redeploy that and make sure that we actually copy that storage path so we're not dealing with the same issue. Change greeting, we'll borrow the hello world admin from the right path, give it the, I'm just going to give it the short version, and now I should be able to execute that. When I get greeting, I should see hola. There we go. So that went through. Cool. So just to give you a visual representation of what we just did, we have, zoom in a little bit here, the first version of our contract deployed hello world to account 6, and that's basically all that was stored on that account. Public getter, public setter, no worries there. Problem being, of course, that anyone can call that. What we just did is we deployed that same contract, but we defined an admin and stored that in that account. And that admin is actually what restricts the access to the setter method. So if, for example, account 6 were to move that to a different account, let's say account 7, our contract wouldn't know that account 7 now owns that admin and is now calling that method. It really doesn't care. And that's the benefit of the capability-based access control and the resource-oriented paradigm that is Cadence, is it kind of maps to how we think about ownership in the real world, right? So if I want to give you access, Cole, right? Yeah, if I want to give you access to the castle, I would give you the key, and now you have access to the castle. No one really has to know about it. You just have access to it, and that gives you entry into the castle that we're in. I would lose access, exactly, yeah. So the other thing about resources is that they have existence and uniqueness guarantees. So once you create one, there's only going to be one. If we call this, for example, to be specific, if we call this create keyword only once in the entire existence of the contract, then there will only ever be one admin on Flow, and so exactly when you transfer to someone else, you'll lose access, they'll gain access. That actually is a perfect question to lead me into the next point, right? So let's say let's say it's a DAO contract, or I don't know, you're running a treasury on chain and you want to share access. How would you share access in a way that would allow you to later revoke it? So kind of like this hierarchical concept, similar to, if you add an authorized user on your bank account, if you allow someone to have an authorized user card, you can always revoke it, but they'll still have access to the same account that is still in existence. So in Cadence, again, using capability-based access control, you could actually do something. I'll run a connector here to this guy, and I'm going to name that a capability. And so what that allows you to do is now, instead of giving account 7 the admin, I'll get rid of this proxy. Now account 7 can hold on to and store that persistent capability. And now both have access. But if account 7 updates or sets the greeting to something that's just not allowable, account 6 can just revoke that capability. And now account 6 is back to having the only access on the contract to set the greeting. So just looking at time. Yeah. Like automating if there's some condition. Yeah. So you can, it depends on how you code up the proxy. So I'm looking at time, and actually we're doing pretty well. So let's just write out the proxy. What does that look like? So I'm going to take this admin, and I'm going to create another resource. This resource is going to be an admin proxy. And this admin, just like we talked about a second ago before I deleted everything, needs to store a capability. So let's assign that admin capability. So this is going to be access. Let's just make this access all, let admin. And this is going to be of a type capability. We need to define what that capability is actually going to be on, and that's going to be an admin. But of course, like anything that we define, any data structure, we need to initialize it. And so in our init block, we're going to take an admin argument, and then we're going to assign it as self.admin, missing a parentheses, and equals admin. There we go. So now what happens? Now an admin needs to, so in our example, account 6 would have to give a capability to account 7, and in the same transaction, account 7 could use that to create an admin proxy and save it in their account. So really, an admin proxy doesn't do much good without a capability. We can make a method on here that allows us to create an admin proxy, and I'm just basically going to copy this here. Function create, I'm just going to say create proxy, and that's going to return an admin proxy. What are we going to return? We're going to return a proxy that we create. We're dealing with a resource, so we need to use the move operator, admin proxy, and we're going to pass that admin, and boom, there we go. So now account 6 needs to get this capability to account 7. How are we going to do that? So we're going to need basically 2 transactions. Account 6 will create this capability, and it'll publish it for account 7 to claim. Account 7 will take that capability that's been published for them in the subsequent transaction, capture it, and save it inside of this admin proxy. And if at any point account 6 wanted to revoke account 7's access on that admin, they could just revoke the capability and do that. So you asked if you could do it programmatically. So I don't believe there's a way to do that, because actually you have to have privileged access on the account that issues the capability. But you can do things like you can scope the level of access. So for example, if you wanted to say, I don't know, access limit, and that's going to be an int. I'm not going to fully implement this, but you can imagine, you can say, here account 7, you can set this greeting 2 times. And after that, you can no longer access the capability. And so you kind of wrap the functionality that you want and scope it. And you can imagine that'd be helpful for things like, I don't know, on-chain subscriptions, right? Like you have access to 15 Flow every month, up to that amount, or allowances, treasuries, things like that. So all of that functionality allows you to basically grant capabilities, grant access and functionality that's stored on one account with another account. Cool. So just to recap, try to fit more code in here, but it's going to be hard to see. So to recap, we went from a contract with a field to a contract, a field with a setter, and now a contract with a resource that gates access to the setter. And then further yet, we could go ahead and delegate a proxy. This is supposed to be intro, and I don't want to dig too far into capabilities. I would like to get into some tooling. I think what I'm going to do is just, now that we've seen what it would look like to wrap a capability, I'm just going to focus on the actual resources here, and rather than kind of like transmitting capabilities between accounts. So to refocus, we have this admin resource that's in account 6, and that allows us to set the greeting. So let's go ahead and deploy this to Testnet. Flow Playground is basically a local environment that allows you to kind of iterate pretty quickly and play around with cadence. But any contracts that you actually deploy to production, you're going to want to develop locally. So the tools for that are going to be primarily Flow CLI, and you're going to want to use the Testnet faucet so that you can fund your account. So what's Flow used for on Flow? It's used to pay for transaction fees. It's used to rent storage. And then also actually the link for the slides too, if you want to take a look at the QR code you can get right there. But here, I'll put that back up for you. Apologize here. So using Flow. So you have access to you use Flow to pay for transactions and to rent storage. So you store things in your account. You have to have enough Flow to fund the storage for that account. So we have to get an account on Testnet. Let's go ahead and go to the Flow CLI docs just so you see what that looks like. I can go to Flow CLI, I can install Flow CLI, pretty easy on a Mac, brew install Flow CLI, and that will get you pretty much the primary tool that you need to be able to develop locally using Cadence. So I'm going to go into my terminal here real quick. I don't think you can see that, but let's go ahead and clear. I'm going to say flow init, clear again, flow init. I'm going to init my project here, and that's going to be flow init hello world, and this will set up basically a basic framework for what a project would look like using Cadence. I'm not going to install any dependencies. You can, like if you're trying to build a fungible token or an NFT or anything using the core contracts. I'm going to skip that for now, and I'm going to change into hello world and open up my VS Code. So in here, this is part of the reason why it's helpful to start out with something like Flow Playground, because it kind of dictates to you what your project format is going to look like. My computer's not cooperating with me. There we go. So out of Flow init, thanks to the awesome tooling team, Cadence and Jordan, you can really easily start up your project. So in here we already have contracts, we have scripts, and we have transactions. We're not going to use these, but this can be really helpful. You also have the Cadence testing framework, so you can write your contracts, transactions, scripts in Cadence. You can also write your tests in Cadence. We're not going to use that for right now. What I'm going to do is I will open up my terminal in VS Code and remove Cadence. There we go. So I'm going to remove these examples. Don't need the test for right now. And I'm going to go back to Chrome and grab my contract with the admin resource. And that's my contracts. Create hello world.cdc. Paste that. Cool. So that's the same contract that we just used on Playground, but we're about to deploy it to Testnet. So let's see what that looks like. First I need to create an account and fund an account on Testnet. So that's pretty easy. With Flow CLI, you can say flow accounts, create. I'm going to name this account Testnet hello world, and I'm going to select Testnet as the network. That's going to create a Testnet account. Just a side note, accounts between like Testnet and mainnet are going to be different namespaces. So whereas across different Testnets on EVM chains, you'd be able to use the same EOA, not necessarily the same because we have a protocol native account abstraction. So let's grab the address that was just created, and you can see my balance is pretty low. I want to go to the faucet and fund that. So that's linked in the slides here. All you need to do is paste your address, prove you're not a robot, and hopefully I pass. Fish. There we go, verify. And you're going to get a whole 100,000 Testnet Flow token. And that will be more than enough to do most things, unless you're like funding liquidity pools on Testnet. Great. So now I have my funding, and I can go ahead and deploy this contract. So whereas before on Playground, it was just as easy as pressing some buttons, a couple CLI commands, but they're relatively intuitive. And we have docs as well on the developer docs. But let's go ahead and add Flow accounts, add contract, and my autocomplete's working here for me. I'm going to add the contract. I add the path to the contract, and I add my signer, the one that I named as Testnet Hello World, and name the network that I want to deploy to. So let's add that contract. And once it's on Testnet, we can use some community-created toolings, community-maintained tooling, to inspect that code. One of the big advantages of having a Cadence contract is all code is visible to everyone by default. So you don't need to worry about if a contract is verified. You can just go to contractbrowser.com and type in either the address or the contract name and view that contract code that we just deployed. And it's pretty easy to, if you wanted to build on this, for example, if you wanted to build the admin proxy in another contract, you'd be able to do that. You just import this as a dependency into your local project. So we can see that code there. So let's actually take a look at the account model, flowview.app. So this is another community-based tool. This will allow you to explore the different aspects. Actually, let me make sure I'm on Testnet. So you can explore the different aspects of accounts on Flow. So we can see our balance, of course. You can see any keys that are currently active. Notice that you have the ability to set the weight of keys. So you have like protocol native multisig. You can see any contracts that are stored on that account. This is that same account that we deployed the Hello World contract to. And you can see anything that's stored in the privately accessible storage namespace. Here's our admin. You can see it's uniquely identified by a UUID. It's not even a field that we added. That's just unique to any resource. And the public paths. So if, for example, we wanted to make, for some reason, the admin proxy public or the admin public, we could create a capability on that same account that's publicly accessible that would allow anyone to be able to set the greeter or set the greeting. But for right now, basically by default, you have the ability to view your Flow token balance as a public capability and received Flow tokens. Of course, you want anyone to be able to deposit to your account, so that's accessible there. So now that we have our local project set up, I guess let me stop there. Are there any questions so far? No. All right, so let's take a look at the transaction. We'll be able to run this on Testnet and check out what a transaction looks like on the block explorer. So I'm going to change greeting, CDC. I just copied what I had on Flow Playground. And when you're working locally between Flow CLI and the Cadence VS code extension, that's something else you'll want to make sure that you have installed, Cadence VS code extension for linting. You have the ability to basically alias your contract imports. So if you have your flow.json dictating where your hello world source code is, by just basically putting this into quotations, you don't have to worry about the actual deployment address. So awesome. Let's go ahead and run this transaction. Yeah. So you could pull any contract here. Yeah. So if I go back to contract browser, let's just go back to contract browser. Let's go back to the home page and let's look at Testnet. So on here, you see a bunch of contracts. You can see the top imported contracts. If I wanted to make a non-fungible token, I could go here and I could import, I could create a script that imports non-fungible token from that address. So that's what that would look like. Yeah. So this is all on the Cadence side. I guess one of the big distinctions is the way that contracts are imported are going to be a little different. Contracts on the EVM side, you're basically building that as you compile your contract code. In Cadence, since these are deployed to accounts, like as code stored on accounts that are like just publicly deployed, you're pulling that code from that account. You're basically telling where your transaction to pull that code from. And so that's where that code is being imported from. Does that answer your question? Yeah. Okay. Oh, interesting. Yeah, cool. Yeah, there's some cool stuff going on with ordinals that like kind of mind blowing. All right. So we are looking at running this transaction. So we're about to run it with the account that has the admin, and that is labeled in our config testnet hello world. So I'm going to run flow transactions send. I'm going to tell my CLI where that transaction code is. I'm going to give it an argument. We look back at that change greeting. Actually, I just realized that I misspelled that. Change greeting. I need to give it a signer, just like I did testnet hello world, just like I did when I deployed. And I give it a network, which is going to be testnet. So now when I run this, again, we're going to access the admin and we're going to set the greeting. So let's go ahead and run that. And you'll see that you get a transaction ID, and that should have gone through. Let's check it out on the block explorer. So the block explorer there are two block explorers that you would use on Flow. You have an EVM side block explorer for things that you run on the EVM side. This is, we're talking Cadence right now, so let's go to flowscan.io. I'm going to input the transaction ID, and I should get the transaction that I just ran. And you'll see that Flow CLI automatically replaced the alias for the network that I had specified and ran that transaction. The other thing that's really nice about transactions is there's not like ABI encoding. You're able to actually view the code as it was written when you run it. We can also see any events that were emitted. There are none in this case. We can add some actually just in a second with a contract update, and any assets that were transferred. So this is on flowscan.io. Great. So now we can return back to our contract. And something that you'll definitely want to incorporate into your contract design is events. So these events will be emitted anytime something happens, wherever you define them. For our case, we'll go ahead and create an event. Pretty simple. You're just declaring an event. You're naming that event, greeting, updated, and then you can add parameters here. So I'm going to add the greeting updated, and I'm going to just emit the new greeting. I'll add that into the contract method. I'm going to emit greeting updated, and I'm going to just pass exactly what was updated. Awesome. So another big benefit of writing contracts with Cadence is you have upgradable contracts just supported by design in the protocol. So I just added that to the local contract, but of course I need to actually reflect that on Testnet. So pretty simple, flow accounts update contract. There we go. So I'm just defining, similar to adding the contract, I'm just telling it the path for the code, the signer, and the network. If this was a non-upgradable change, I just wouldn't be able to update the contract. So it's much simpler than you see, for example, with Solidity, where you have to incorporate and kind of preemptively design for the upgradable contract. In Cadence, you just make your change and you update your contract. So the next time that we run the change greeting transaction, what we should see is that an event is emitted. Let's make sure that that actually went through. I could see that it was updated. That looks successful. Great. So let's run that transaction. Again, I'm going to run that same transaction that I did. I'm going to turn it back to hello world. I'm going to run that. And then we'll copy this transaction ID. Once it confirms, we'll go back to the block explorer and take a look and see. We can actually see that the event was emitted here, and we can see exactly what that was emitted to. In the block explorer, it looks pretty similar. Right. So let's say you see a contract on Contract Browser, or you came across one like on Twitter or something, on GitHub, and you want to interact with it, but you don't want to have to set up, this whole project and install all these dependencies. You could do that pretty simply with a tool called Flow Runner. And I've linked to that one in the slides as well, but that's another community managed tool. So I'm going to import hello world, I'm getting my languages mixed up, the world, and I'm going to add the address from which that contract is deployed to. And I'm going to return a string. I'm going to return greeting. So this tool will allow you to execute transactions, or in this case, scripts. So transactions you would sign with your Flow wallet. If you have Flow wallet extension, it is not currently working for me on Testnet for some reason. I think it might be an issue on my end. But in our case, we're running a script, so we don't need an authorizer. So I'll just run that, and you could see that you're getting the field from the contract. So we could do that with another contract. Most contracts, for example, non-fungible token, these are going to be interface contracts. You can also do that to inspect accounts. So that's actually exactly how this tool is working. The really cool thing about this ownership model, this resource-oriented, go ahead. Right, so scripts are going to be non-mutating. So anytime you run a script, it's view only. Even if you were to call, for example, that public set greeting from the context of the script, it wouldn't be persistent. Exactly. So anything that's being executed in a script is just going to the access nodes, kind of the edge nodes, the data availability nodes, and it's not going through to the execution nodes. It's just, but you can use scripts to inspect account storage, even though you don't have an authorizer. You still, within that context, since it's non-mutating, can access account storage just to view things like that. The really cool thing about this ownership model is whether or not someone owns something is just a matter of checking in their account. So if you've ever tried to answer the question, for example, like what NFTs does Marcus own, right? You'd have to look at indexers, and you'd have to look at state off-chain. On Flow, all I'd have to do is look at Marcus's account, see what NFTs are in there. And that's just like a mental model that really maps to the real world. So, if I wanted to give you $5, I would just take it out of my wallet and hand it to you. I wouldn't have to necessarily go to some contract and tell it to update your balance and decrement my balance. So it's much more intuitive. The other thing that it lends itself to really well is composability. So returning back to this example, I could define this admin, and just as I mentioned earlier, let's say I want to add some scoped access that I can delegate. I can write another contract without even having to coordinate with the author of Hello World and leverage the capabilities and put it inside of another resource and compose on it that way. So these resources really can be treated like building blocks that allow you to extend contracts even if you're not updating the actual code of that contract. So, do you have any questions so far? I feel like I got through most things here. Yeah, so just returning back to the slides. Yeah.
In terms of accessing data and an authorizer, is it possible to do private data or store secrets on Flow?
I mean, you can store anything that you want. So if you encrypt the data before you put it on chain, you could definitely store that. And then on client side, you would have some decryption key that you decrypt that data with. I don't know of a specific instance that I could point you to as an example, but I feel like people have played around with that. You could probably just ask around in Flow Discord and someone would know. But yeah, you can definitely store. I mean, people have stored all sorts of crazy things like emulated Game Boy startup. stored MP4 like video files on chain. The storage model and like honestly the transactions that we ran were like fractions of a cent. Storage and transaction fees on Flow are very, very inexpensive, and that translates also to Flow EVM.
But isn't like the account model allowed to hold, like if they're holding a resource that hasn't any public capabilities, it means it's private, like you cannot access to it. You cannot view that data unless you are
Yeah, so like you can view it from like a script, but you wouldn't be able to access it, right? So if I put the greeting inside of this admin, and even if I define it as access all, right? If I put that there and I left it in storage exactly where it is initialized, then you wouldn't be able to use the greeting that's stored inside the admin because it's not accessible to the execution runtime.
Right, you wouldn't even be able to know what it's saying. That's what I'm trying to say. So that it will be like a kind of a private data in a sense?
You would still be able to see what it is at minimum when it's committed to the chain. So like I could look at the transaction. The other thing is from a script, I can actually, you wouldn't typically be able to do this in a transaction because scripts are read only. You can actually, I could like do this, address. I'm gonna take an address and I'm gonna access a let account equal get auth account. And I'm gonna authorize storage on the account that I'm accessing. And that's going to be the account object of the address that I give it. So now I have something that I wouldn't normally be able to have access to. So from here I could say let admin equal, basically I would be able to borrow the admin and then access the greeting field and return that. So even though that's not accessible in terms of being able to like compose on it, if it's in storage, I would still be able to at least view the data. So there's not privacy in that sense. Yeah. Anyone have any other questions? Cool. Well, I guess, yeah, if you think of any, please come talk to me. If you can think of any novel ideas or have any questions about how Cadence and EVM interoperate, I've spent a lot of time working on that stuff, and so I'd be really happy to just pick my brain or ideate on things that you're working on with your product and how they can help you out.
Out of curiosity, can you use Cadence to store things on chain as a database or a data lake?
I mean, sure. I mean, you can create like some kind of basic storage protocol for how you want to store data, and then how you transform that data when you retrieve it on chain.
Is there like a rent fee or rent cost?
Exactly. Yeah. So actually, if I go back to Flowview, I can see this is my balance. There's a disparity between my balance and my available balance, and that difference is being used to rent basically the storage bytes that you see it consume there.
Got it. And once those bytes are gone, you get that back.
Yeah, exactly. So if you just remove that, I don't believe you can remove a contract on Testnet or mainnet, but yeah, I mean, if that's the only thing that's taking up code, anything that you remove from your storage frees up that flow to be basically claimed or used again in something else. Yeah.
So with Cadence and the EVM, they are synced, right? It is like the transaction I had done in EVM also reflected in the Cadence?
Yeah. So I guess another way to put that, I'll try to rephrase it to make sure that I understand the question. So in Flow EVM is EVM equivalent runtime on Flow. If you never want to touch Cadence, you can deploy your contracts as Solidity contracts, interface with Flow. You still get the sub-second block times and all the other protocol benefits that you get by running your contracts and transactions on Flow. Just you're doing it via EVM. Those transactions are basically wrapped in Cadence, and so anything that happens in EVM is visible from Cadence, and there's like this directional relationship between the two. So I mentioned earlier that even if you're an EVM developer, you still can leverage and kind of sprinkle Cadence into your product to basically level it up. And one of those ways is by, I'll take an example. So when you go to a DEX, you have to approve and you have to swap, and those are two distinct operations. You could use Cadence to have one single confirmation, and you'd be able to do the approve and the swap in a single Cadence transaction. And you can extend that, right? You could do like 10 different EVM operations to create more complex user flows that really reduce friction. Yeah. Does that answer your question?
Yeah.
Okay, that's cool. Yeah, awesome. Well, thank you guys for your time. Appreciate your attention.
I really like.
You're not live streaming. No, that'd be funny. 10 minutes of fame.
I want to.
How would you deploy